Ever wonder why your phone's voice assistant mishears you? Or why an AI diagnostic tool might wrongly claim you have a rare disease when you just have a cold? The answer lies in a critical concept: uncertainty. Today, we're diving into how cutting-edge AI research is teaching machines to recognize their own limits, and why that's a game changer for reliability, safety, and trust in AI. Let's start with a hard truth: AI isn't perfect. When you ask a chatbot a question, it's not simply retrieving facts. It's generating responses based on patterns it's learned from vast datasets. But what happens when those patterns don't align with reality? That's where uncertainty quantification steps in. Think of it as equipping AI with a confidence meter to gauge how certain it is about its answers. Imagine training a model to identify cats in images. It excels with fluffy kittens, but what if it encounters a cartoon cat or a sketch? Traditional AI might still classify it as a cat, even if it's wrong. Enter SBMC, Scalable Bayesian Monte Carlo, a method that doesn't just make predictions but measures confidence in those predictions. Here's how SBMC works. It's like letting an AI explore a maze, not just sprint to the exit. Instead of choosing one path, it tests many, tracking which ones hold up. This exploration relies on two core ideas. 1. Bayesian statistics, a framework for updating beliefs as new data arrives. 2. Monte Carlo sampling, a technique that uses randomness to simulate possibilities. By adjusting a parameter called SBMC balances between strict certainty and cautious uncertainty. It's like a GPS that says, "I'm pretty sure this is the route, but let me check a few alternatives just in case." But here's the breakthrough: SBMC scales. Large models like GPT or BERT have trillions of parameters, making traditional methods impractical. SBMC tackles this with tools like ZRO, which distributes model training across multiple devices, and Tensor parallelism, which splits mathematical operations across GPUs. It's akin to giving a giant robot a team of tiny helpers to handle the workload efficiently. Let's test this in practice. Researchers evaluated SBMC against challenging datasets. MNIST7, a cat classifier exposed to dogs, noise, and distorted images. IMDb, a spam filter analyzing appliance reviews instead of movie reviews. CIFAR10, a car detector spotting street signs or random textures. SBMC didn't just guess, it identified when it was uncertain. Traditional methods like DE, which averages multiple guesses, often missed edge cases. SBMC, however, acted like a cautious detective, flagging anomalies with phrases like, this doesn't look right. The results: SBMC outperformed conventional approaches across 4 key metrics. Precision, how many flagged items were actually incorrect. Recall, how many real errors did it catch. F1 score, a balance between precision and recall. Uncertainty calibration, how well did the model's confidence match its accuracy. So why does this matter? As AI infiltrates healthcare, autonomous systems, and critical infrastructure, being able to trust its confidence is vital. SBMC isn't just a technical win. It's a step toward AI that's not only smart, but wise enough to know when it's not. The next time your voice assistant stumbles, remember, researchers are hard at work making sure the machines of tomorrow don't just guess, they understand their limits.